Ladies and gents, welcome back to another Engineers podcast. Today we're joined by Viman, who is founding engineer and head of product engineering at Kumo AI. Kumo uses artificial intelligence, AI, to accelerate the creation and performance of machine learning models. And we're bringing Viman on, who's going to tell us all about how they're doing it. And they've got a pretty star-studded founding team. So I'm looking forward to getting into some of the details around what these guys and girls have been building over the last 3 years. So first and foremost, Viman, thanks for coming to join us. How are you?
Good. Thank you for having me in your show, Elliot.
Absolute pleasure. Absolute pleasure. We always start with an intro into your background. So that's just as star-studded as your founding team. Talk to us a little bit about your background, where you've come from an engineering perspective.
Yeah, I would love to briefly go over my journey. I started in the Bay Area in 2012 at Google. I was working on Google Wallet and its integration with Gaia, which is Google's centralized authentication and authorization service. In 2014, I moved to LinkedIn, where I spent about half a decade working on a wide range of roles and projects. So I started in the team responsible for companies' data and company pages. And the CEO of LinkedIn back then, Jeff Wiener, had this amazing vision of creating an economic graph consisting of LinkedIn members, jobs, skills, companies, which would be interconnected, and data would flow beautifully, allowing us to build very rich applications. One challenge was that we didn't have enough companies' data. So we went ahead and we found a lot of open data sets, company registries, and so on and so forth, about 60 such different data sets. But then there would be a lot of duplication across them. So that's when I got my first exposure to machine learning. We built an unsupervised clustering model, which didn't work that great. Then we built kind of a union finding algorithm with each set denoting a single company, and then the question whether a company belongs to a set or not was a binary classification problem, which we built a random forest classifier for. So I was completely blown away by this technology because there was no way we could handwrite a solution to that problem. So just let it learn by data and automatically build a model which spits out the results and outcome we are looking for was completely amazing for me. And I could see it very clearly that this would change the world. And rest was history. The next 10 years is, AI has completely taken over the world. So, I was very fortunate to get early access and exposure to build a practical application using this. We were very successful. We went from 3.5 million organic company pages created by LinkedIn members to over 20 million. And we had a much richer economic graph. So I moved to hiring platform after that. I worked in creating LinkedIn's first ATS, which is applicant tracking system for small and medium businesses. I spent some time there. I also played a number of leadership roles at LinkedIn. I was part of the data model review committee, which is responsible for approving new APIs at LinkedIn. I was also the chairperson for the RFC committee for LinkedIn Talent Talk, which is basically more than 300 engineers. Then I worked briefly on the jobs recommendations model at LinkedIn, which is, again, like very data science, machine learning heavy. From there, I moved to Uber. And at Uber, again, I was very fortunate to be part of the Uber AI org, which is the central org for helping building foundations of AI and machine learning models for a variety of our stakeholders. The beauty of being in the Uber AI org is that you get to work on projects which is kind of impacting pretty much all of Uber. So I started working on the black box optimization platform, which was used by pretty much every team to hyper parameter tune their models. And Uber models in 2018 were largely tree based. There was still a movement to move them to deep learning, and typically for tree based models, tuning has a lot more significance than for deep learning models. So I had a great time there. I worked on embeddings platform after that at Uber AI, and one of the notable models you would see where my team contributed significantly is the Uber Eats home feed ranking. So if you open up your Uber Eats app and you see a bunch of restaurants, that recommendation is coming from the model which my team was building. So all of that led me towards Kumo AI, which is basically a platform which we allow customers to build machine learning models on. And that's how I started. I started as a founding engineer. It was a small startup. I think I was the ninth hire, but we are growing so fast that I joined 3 months after signing the offer, and I was already the 16th hire from signing to joining. And then yeah, so since then we've been growing phenomenally well. I think we've amassed some amazing customers. We have solved some really powerful real world use cases, and yeah, that's where I've been for the last 3 years.
Love that. LinkedIn and Uber, two products and a number of different teams that I know really well. Two names that are associated with doing some incredible engineering stuff at some serious scale. So good for you. No doubt, a really good learning ground. And obviously, you're taking that into Kumo. Do you want to give us a bit of insight into and almost like the elevator pitch of Kumo AI and help us understand more about what the business are doing?
Sure, yeah. So Kumo is an enterprise AI company. That enterprise is built machine learning models on top of relational data. The beauty of Kumo is that the traditional data science and machine learning workflow is not required anymore. So, no feature engineering, no training table generation, no comprehensive data transformation, aggregation pipelines, no training infra, no serving infra. So, all of this abstracted behind two lines of a simple query, which you run directly on your relational database. And this query is written in a DSL which we have created. It's called the predictive query language. It's very similar to SQL, except that with SQL, you can only query the past, but with PQL, you can also query the future. So think about writing a SQL query with dates into the future, and we train a model underneath and deliver you those predictions. So I think it's phenomenal. And initially, when we started, our goal was to make machine learning easy, but the underlying technology we use, it also allowed us to not just make it easy but also build really high quality models. And we talk about that briefly. So that is kind of very unexpected, because you can either build a product which is very easy to use and delivers reasonable and moderate value, or you can build a product which delivers very high technical value but is very hard to use, and it requires advanced experts to navigate their way through it. But we've managed to kind of do both together. So we've had customers where they bring in their models which they've been working on for many quarters, and they bring their data to Kumo and train their first model, and within like the first 2 days they have a model which performs better than their existing model. So it's not just a productivity tool, it's actually a tool which just lets you build models which are like really accurate and state of the art, right? So that's where we are. Our goal is to make machine learning easier than analytics. And this is like really a revolution in predictive AI which we are chasing, and I'm confident we'll deliver on it. We have a great founding team, and we have like some amazing talent here. So we are very well strategically placed to deliver on this, and I think we are on a great path.
Yeah, good. That's the thing that I love, and I can hear that loud and clear. The creation, the speed, the performance of machine learning models, removing the abstraction, you touch on that, no, is really important to help teams come up to speed. I think it would be really good to dive into a couple of use cases because beautifully put on your website gives you a really good indication as to some of the great work that you've done. Help us understand a little bit more about the use cases for teams and businesses and where they can actually start using Kumo.
Sure. So the beauty of the platform is that we are not tied to a specific kind of machine learning model. So we have customers who are large social networks. We have customers who are into grocery and food delivery. We have customers who are large scale hospitals, and then we have customers who are large fintech banks. Right. So as long as you have data represented in relational form, which is pretty much the entirety of the data in the internet, right? Largely, you can basically build any model by writing a specific query. Where we have really shined in the past is actually these like, kind of four categories, which is recommendation models. So think about you go on a website and then that website is trying to sell you certain products, and they have a large inventory of 2000 SKUs, and they have to determine what are the top 10 items they should be showing you, so which maximizes the probability of a purchase. So we really shine for those kind of use cases. We are doing exceedingly well for fraud use cases. So if you have a large history of customers, and then some of the customers have been fraudulent, our model can learn really, really well to predict which of your customers would be fraudulent. It's a huge financial impact for fintech institutions. Those are definitely two like really, really high power use cases. We have been into advertising use cases where customers have taken over embeddings for their entities and tried to optimize their ROAS, which is return on ad spend. That has been working great. So, like I said, we are not bounded by specific areas. We did in the very early days when we were trying to find the product market fit, had to build a couple of foundational models. But, the good thing about our machine learning engine is that it doesn't need to really be specifically tuned towards a use case. It's very, very generic, but still builds very specific and high quality machine learning models.
Okay. Can you actually help us understand by breaking this down for us how AI can actually accelerate the performance of machine learning models?
Sure. Yeah. So let's jump right into kind of understanding how Kumo does this, right? So when we say we are using AI to build machine learning models, the AI is really a graph neural net. And the benefits of graph neural nets is that you don't need to perform any feature engineering automatically. Right. So let's try to learn how that happens. So traditionally, when I was working at Uber or LinkedIn, like we hired a lot of very high quality data scientists. A lot of their job in working on building machine learning models would basically be feature engineering, where they end up with this training table where you have a large number of features and a label, right? And these features would be like, let's say if you're building a Uber Eats home feed ranking model, then there'll be features like number of orders you made in the last 60 days, number of Italian orders you made in the last 20 days, number of orders you made on a Tuesday. It's pretty arbitrary, and I think like good data scientists use intuition to understand what kind of signal to the model could help improve the performance, and then they implement that signal, and then they would try to test that model offline, see if they get a performance boost. If they do, they'll basically ramp up an experiment to launch that experiment online. It's a very long cycle to try to find the best set of features. And a lot of the machine learning teams, this is what they're doing essentially, trying to find the next set of data representation which can improve the performance of their models. Now, the way graph neural net works is it works directly on top of your relational data. So you don't need to perform those aggregations, those transformations, that single feature table. As part of training the model, the graph neural net will actually go through your entire graph and try to retrieve data which best represents your model. So, as part of training, backpropping from the loss function will sample your graph and we'll try to see what data is causing the loss function to improve. And as part of this aggregation, we use transformers, which is same technology which GPT uses for language models, but we're using this for relational data. And it automatically learns those aggregations and in a non-linear way, which is actually like even better than writing features like 60 like, number of orders in the last 60 days and so on and so forth. Right. So the end result is that as you're training the model is automatically performing feature engineering on your entire topology of the graph, right? So it learns from the data, it learns from the number of edges, topology, the entire graph properties. And that's why sometimes when you're doing manual feature engineering, you're obviously limited by the imagination of the data scientist. And we have some great data scientists in Silicon Valley, and they've learned the art and they can do this really well. But with Kumo, you basically find the best set of features on day one when you train your model. So you don't have to go through those iterations quarter after quarter to try and find your best model. So that's really where I think we are able to differentiate ourselves as a machine learning platform. And what we have done is we have built a bunch of peripheral platforms to support the GNN training and the PQL abstraction I spoke about earlier, which makes using graph neural nets very, very easy. So it's not easy to train a large scale graph neural net model. So many of our customers actually use us for simply graph machine learning as a service, even though our value prop is just making machine learning so easy, right? Because graph neural nets, they work phenomenally well on relational data, right? So that's how it kinds of uncovers like how we are able to build these great models. Another analogy I really like to give is if you think about what happened in the computer vision era, right? Like we initially had people build in these small features, like trying to write algorithms to find three connected pixels, which denotes a line, and small circles, and then they would write more features on top of that to try and connect those things to find a bigger shape, and then classify images. And then we had convolutional neural nets, which basically would slide a window through the image and automatically perform the convolution operation and find those small shapes, and then increase the window size and then find bigger shapes. And we had massive performance boost on model performance for image classification. So we are kind of doing the same thing for relational data. So we slide a window over your relational data, and we automatically find the best set of features to represent your model. So that's where we really that's how we really distinguish and build like really really high state of the art models.
Love it. Has the mission of the business deviated at all as you found product market fit and you found how you've been able to provide so much value back to your customers, probably as you've continued to build the product? Has the mission deviated at all? Was it really a crystal clear vision of actually, we believe that we're a better case and companies should eliminate data science? Do you feel in your journey there?
Yeah, so I would say the mission hasn't deviated. The first product market fit we have basically been there, fortunately. And this is surprising because I work with a lot of startups as an advisor or investor. And, typically startups see three different companies in 2 years, right? So we've been here for 3 years and we've kind of like stuck with the same mission because it's so powerful. And if we deliver on it, I think it's like extremely high value. The TAM for predictive AI is really, really large. It's actually significantly higher than Gen AI at the moment, right? So the mission is still the same. We have obviously, as a startup, pivoted based on customer feedback, and sometimes they tell us, "Hey, we need some more control over what we are doing." So, for example, we had a UI product in the past, so you could connect your data in S3 Parquet or Snowflake or Redshift or Databricks, BigQuery, Azure, and then you could create your graph, and then you could write predictive queries. And then they told us that, hey, we need some more control. So we started to offer model planner settings, which basically allows you to customize some of the aspects of the platform. Then our customers told us, hey, we would love to like do transformative EDA. So you want to train the model, get the results, and we want to go back. So for some of our advanced users who understand GNNs and they want to play around with our platform more and get more access and control, so we build the SDK, which is basically it's a very simple and intuitive programmatic access to Kumo. So you can connect your data, again build the graph, train your models, look at the data in the same notebook, and go back and start from cell one, making the required changes you want to. So I would say most of our effort has been towards just catering to our customers to provide more different aspects of access to Kumo. It's really not changing the core of the product. You did mention one thing which I do want to definitely address. So we are not eliminating data scientists. I think what we are really doing is making them very powerful, right? So as a data scientist, if you're building one model in a quarter, now you can build five models. Like many companies, maybe barring Google, Meta, and some of those big tech giants, they don't have budget to hire like five data scientists for each of their use cases, right? But they do want machine learning to power like bulk of their website, right? So that's what we are really going after. So you have a lean team of machine learning or data scientists, machine engineer data scientists. we can basically empower them in a way where they can create significantly more number of models and more accurate models than what they would have done using the traditional way for predictive machine learning, right? So that's basically what our real pitch is. And yeah, I think again, we will keep listening to our customers. I think that's what startups need to do, and iterate on that. But the core engine has been constant.
Yeah, that's actually a very smart frame and smart business play. Building an offering where you can actually get five, in essence, really talented people for the value of one. Um, Help me understand a bit more about. You spoke about core engine, and not necessarily even Kumo's core engine, and we're trying to understand some of those product and engineering challenges. I'm really trying to understand and would love to understand what engineering looks like at Kumo, because we're talking about some really interesting challenges that you're solving for businesses. When you get under the hood and understand Kumo, what are we likely to see and what problems are you guys solving on a day-to-day basis?
Sure, yeah. So let's break down the architecture a little bit, right? And I would also like to tell you about the different deployment modalities, which will kind of, answer your question on, if you break down Kumo, what do you see underneath, right? Where are the technical challenges? So we start with customers' data. So we have a data platform, which basically will help us bring in your data and seamlessly transition it into a taxonomy or structure which Kumo would understand better, right? And like any products which works with external customer data, so data is in a variety of shapes and forms, and it can be sometimes very dirty, sometimes in a weird structure which you've never seen. So every company which is working with customers data has to go through that journey where we have to iteratively process one block at a time, and just kind of get a very comprehensive coverage of what are the different data sets we can probably encounter, right? So many of our initial design partners and even initial customers, we had this journey where we would provide white glove support to them to understand what are their data requirements, right? So we have a very comprehensive data platform which is built in a very versatile way now to process even data situations which we haven't encountered in the past, and a lot of this has been our learnings just working with customers. So that's the first component. The second component is we need to convert it to a graph, which Kumo can understand and train a graph neural network model on. So we basically perform data materialization, which also happens on the same data platform, and it basically actually converts to certain extent encode features and kind of position us for training. The third component is basically the training infra, which is responsible for actually training the model. So we have a feature store, which is basically kind of optimized towards providing features for a sampled graph, which we use when we generate mini batches for training. And then this feature store works with our trainer module to allow easily and in a very fast manner uh, subgraph sampling and providing the data to train the model. Right. Then we have our standard training infra. We run on one GPU. We don't have a multi GPU situation right now. Practically, we found that even customers who have terabytes of data do not yet need multi GPU. We are pretty fast with training in a single GPU, so we haven't had to complicate our architecture further there. Then the actual model is is basically built by a research team which is responsible for building some of these foundational models. And like I mentioned earlier, we actually don't have one model per use case or one model per type of use case. We basically have maybe a couple of different variants, and that's about it. So that team is constantly working on building this core engine, which is the GNN module, and which is adaptable to different kind of use cases. So the training infra obviously uses those models to train the models, right? And then when you're making batch predictions, we basically would generate your model, and then we have similar kind of structure to go through the serving infra, which is again on PyTorch. Um, and on top of all of this is basically what we have, what we call the predictive query language. So we can basically define your query. We have a grammar, and then we parse that query and we convert that into understanding the requirements for your problem. And using that, we generate the training table using the same data platform. So that's the core application. Now, we are deployed on AWS for our SaaS stack. So if you basically, come and ask Kumo to provision you an environment, you can go to our website, ask for a free trial. We provision you by default on AWS. But we had many customers who would come in and they have specific data governance requirements. So they don't want to leave the data, like let's say their data is in Snowflake, they don't want their data to leave Snowflake. And they want it to operate within the boundaries of the Snowflake's data center. So we have a native app offering inside the Snowflake marketplace. So think about the way you would go to App Store, install an app, and start using it. Similarly, you can go to Snowflake Marketplace, enable Kumo, and start using it right away. We have a free trial for about 30 days, and your data never leaves, Snowflake. And you can also pay us using your Snowflake credits, so you don't have to go through the cycle of, like getting approval for a separate, application. We have similar integrations with Databricks. You can basically push down compute onto Databricks and run your application primarily in Databricks. Um, so because of all of those deployment modalities, the way we have architected the system is basically it's not tightly coupled to a single implementation. So Databricks and our SaaS offering, which runs on AWS, uses EMR, so which is basically Spark powered, right? So Databricks and our SaaS offering is very similar, but Snowflake uses a different implementation for data processing. They use Snowpark services. So our implementation is abstracted out from our interface. So we have a same interface but a different implementation for Snowflake, and still the entire end-to-end system works seamlessly. We are also working. Recently, we signed a deal with a customer who's bring your own compute. So we run entirely inside their own VPC, which is also, I think, I believe they're also deployed in AWS, but they don't use our AWS stack, right? So a lot of the engineering has been focused on providing those kind of multi-modal deployments across different data planes, different containerized services. So all of this combined together build this multifaceted architecture where we have like the core architecture which I described earlier, and then deployed into these various modalities, right? So that's pretty much how comprehensive the whole technology is.
Love it. Okay. And obviously, everything in the AI GPU space is quite volatile at the moment. Does that impact or affect your business at all?
Yeah, that's a very interesting question. So, like I said, we don't have to use multi GPUs. So GNNs are not as data hungry as LLMs. So we can actually learn very very quickly and build a very good model. So we mostly use single GPUs. We haven't had an issue because of shortage of GPUs so far. Now, this landscape is kind of a demand and supply marketplace, and obviously large language models. There are a lot of companies and very powerful companies being built around them right now. So the GPU landscape is kind of unpredictable. But so far, I would say that we don't have such a strong need for large number of GPUs to train models. So we have kind of not been affected by it so far. That
Nice.
in a nutshell, that's the
Good.
scenario with.
And for what you can share, or where are Kumo placing bets on what space you'll navigate towards in the next 6 to 12 months, as in like problems you anticipate you'll be solving in that period of time? As a business, where are you placing those bets at the moment for what you can share?
Sure. So one challenge with Kumo is, so our product is very, very easy to use. But if you think about testing a POV, which is a standard process in selling, a SaaS product, there is a minimum amount of work you have to do to really establish proof of value. And for a solution like ours, sometimes it is not that easy because you have to build a model. Many of our customers would, we would show them great improvements in offline testing on their previous historic data, but they would want to deploy the model and kind of A/B test, um, and establish clearly that, hey, if we deploy this model, then we are going to get great performance. So that has been one of the reasons why our sales cycles are longer than some of the other typical SaaS companies which have simpler products to deploy. So obviously there is like a lot of effort towards helping build tools which can fasten that process. We are gonna invest in online serving. So Kumo has been an offline batch uh, prediction company right now, but we are going to move to allowing online serving for some of our customers, like fraud, where they have an incoming request and they want to resolve quickly. They don't want offline predictions because by then the fraudster would have already committed damage, right? So we are working on that. I think it's a very interesting piece of engineering challenge for us, and especially for GNNs, where really you have to, during serving, you don't have your like kind of flattened feature store. You have to basically still sample from the graph, and we still want to provide reasonable latency for a reasonably high QPS. So that is another area of investment. We will continue to invest towards being more flexible with our deployment modalities. Although I think like we are already in a space where more than 80% of the time, if you bring in a requirement for how you want to deploy Kumo, we are going to be able to surface that. Then we are also investing in agents to allow Kumo to be able to easily used by individuals who don't even want to learn predictive query language, right? So you can come and connect your data and tell us what you want to do, and we'll generate your notebook or even train a model, right? So those are some of the high level strategic areas we are investing in. And yeah, we'll like I mentioned earlier, we'll basically play it by the ear. We keep listening to our customers, and based on their feedback, we'll keep iterating and improving.
Agents and their architectures and their workflows, everyone's talking about that at the moment. I think that's a really interesting space, and actually, it's quite nice to hear the unique way in which Kumo will try and use it. I'll definitely see in 6 to 12 months where you guys and girls are up to. Help me understand where you might be building the team over the next 6 to 12 months for people listening that are really interested in your mission, really interested in solving some of the problems that you're solving. Where will you be growing and with what types of people?
Yeah, so we have our head office in Mountain View, in Silicon Valley, or now called the San Francisco Bay Area. We are setting up a short office, like small office in Texas as well. We have some presence in the East Coast in the United States, and then we have like several of our amazing engineers in Europe as well. So we have some in UK. Then we have, I think, a couple of really like bright engineers in Germany. So we are not limited by kind of geography. So we are pretty much, if you're good, then we'll, and if the mission aligns with you, then we can basically make it work together. So we also had an engineer in India in the past, and we brought the engineer to Mountain View recently. We still, like, one part of my team still works in India, who are building the UI. So we are not limited by geography in any way. So if there's a good fit, then we can make it work. If you want to move to the US, I think that's a we can always make that happen. It's obviously subjected to the visa situation, but if we can, we have a very strong immigration team which can basically help you, get your way across. In terms of alignment, I think if you are passionate about machine learning, if you think enabling this or using this technology will really change the world, that's what we need. And of course, we have a standard interview process. We'll make sure that your and Kumo's goals are aligned, and that's it. Like, I mean, I don't think we have specific ask on um, you needing to know certain technologies. We are mostly hiring like really good engineers who are problem solvers. So yeah, that's what mostly we look for.
Love it. Good. I think for people listening, if some of what Viman's spoken about today aligns with you, you are a good engineer, you've solved some really interesting problems, go and check the guys and girls out on their website, which is below, or ping Viman on LinkedIn. Sorry, Viman.
Absolutely.
And get in touch with him to understand a little bit more about where they'll be hiring. But I hear the message loud and clear, which is something that you really wanted to drive home to people listening, that Kumo is this new amazing way of building machine learning models. And I think you've done a really good job of articulating how the business actually enables this. So I want to say a massive thanks for coming to join us on the podcast and really breaking down Kumo and where the business will be going.
Yeah, thank you, Elliot. I think great conversation. Would love to share more details to anyone who's curious on. Hit me up on LinkedIn. I'd be happy to connect and answer questions.
Yeah, absolutely. There's some really good content below, which I'm going to share in the description for people to look at, which helps understand some more of the use cases and talks about GNNs and even more of some of what Viman's been talking to us about. So, again, a massive thanks from everyone at Engineers, and of course, the likes, shares, the subscribership. It goes a really long way to continue to contribute to this ecosystem. So a massive thank you. And Viman, again, massive thanks for coming to join us.
Thank you, Elliot.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Engineers.io. It's no underscore. We've also got a website, which is engineers.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.